Okay, Assalamualaikum. My name is Amir Shazwan bin Azuddin. For our project, our group chose to study on a jet engine bracket. Okay, in aviation industry, every mass in each part of aircraft play a crucial role to determine the performance and its efficiency outcome. A greater mass will contribute to the bigger use of fuel consumption, which is not good for performance of aircraft. Jet engine bracket is a critical component of aircraft engines. Okay, for our project, our group chose to use topology optimization of jet engine bracket through SLS process. Okay, what is topology optimization? Topology optimization is a mathematical method that optimizes material layout within a given space with the goal of maximizing the performance of system. Okay, what is defined of SLS process? SLS is known as selective laser sintering and belong to the powder bed fusion family in AM. SLS is a process of laser selectively sinter the powder particle, fusing them and building part layer by layer. Okay, for the objective, the main reason why students write an objective is to let the audience know the aim of the project. Okay, first, to optimize the weight of jet engine bracket by using topology optimization via SolidWorks simulation. Second, to design and analyze the jet engine bracket using SolidWorks software.
My literature review is research about weight reduction in AM, application of AM in aircraft industry, design complexity of ring by AM, and topology optimization. What I got from my research through Sarah Saya Kapalagu 2019, he stated that in aerospace industry, weight reduction is a vital needed and additive manufacturing can provide it. On top of that, AM offer lightweight material, but the mechanical characteristics are same with product that manufactured by conventional manufacturing technique. This means AM adjusts the part weight where the strength of the part is maximized, but the weight is minimized. For years, additive manufacturing has been part of aerospace production. The role is largely limited to units such as internal part or engine parts. According to Singamani 2019, stated while using AM method, it allows the engineer to create freedom of design optimization, which is strict certification requirement faced by aerospace industry. Allowing a design that is a complex shape is very useful for manufacturing process in aircraft industry. Singamani 2019 also stated that AM allow engineer to complete geometric design protection and complexity only play a minor impact on production cost. This statement is supported where O. Paras 2019 also mentioned in his research that AM method offer several benefits that extend to different material groups that complex geometry without equipment and dies to be made. This allows lightweight and dramatically improve of the design. According to Nirish and Rajendra 2020, they stated that it is very challenging to decrease the weight and reduce the material used at the same time the part function remain the same. So, topology optimization is used where the mathematical approach to optimize material structure within a given geometric shape and dimension for a given load and boundary condition. Then, this allows engineers to find a right concept design. This approach also produces new product shape. This is the example of redesigned part that undergo topology optimization. The shape is changed and the weight is reduced, but the structure performance is better.
In this project, I will explain about the methodology. Reverse engineering is a process in which the starting point of a new design starts with an existing design. These methods were adopted to design and validate the improvement of jet engine bracket in terms of weight reduction. The first step in reverse engineering is physical scan. The purpose of this step was to capture a 3D model of a bracket in order to create CAD model from 3D scan data or check measurement for quality control. Step 2 is undergo topology optimization. After create a CAD model, the design model then proceed to simulation analysis by using SolidWorks to perform the topology optimization. The purpose of this step was set to be mass reduction, with the response constraint being the percentage or reduction in mass. And the last step is experimental test of original and optimized 3D printed jet engine bracket. For purpose of AM application, one way to proceed is to export the final model to software that can perform 3D metal printing setup before sending it. For actual part manufacturing using SLS. Next is product function and mechanism. Picture above shows where they put a bracket in a jet engine. Brackets play an important role in a jet engine. The function of bracket is needs to support the weight of jet engine from cracking during handling. It may not only be used at all the time but will remain always on the engine, even during flight. Thus, the job of a bracket is not only to hold the engine in place but to reduce the vibration inside the jet engine. Picture below shows the loading interfaces on jet engine bracket. Loading interfaces are where the area will be subjected to the individual load conditions. Next is the weakness of jet engine bracket. First is low environmental sustainability product. Second, minimizing the weight of any aircraft component has an impact on fuel usage and emission levels. Because fewer raw material used in a smaller part can reduce energy use and emissions. This is important as because the titanium require a high energy level. Third, jet engine bracket has a gross energy. Titanium has a gross energy requirement of more than 15 times than steel. This will make it very hard to recycle titanium alloys. Selection of AM process. From the table on the left side, for the production method on the bracket, selective laser sintering, which is SLS method, is chosen. Compared to SLM, SLS results in lower residual stress. The capability of SLS process to deal with a variety of material make it vulnerable. A very wide of range materials can bow the fuse such as stainless steel, aluminium, and titanium. Then another benefit of SLS parts have a good isotropic mechanical property, which making them ideal for functional parts and prototypes. Other benefit is design with complex geometry can be easily produced by using this technique because SLS does not require support. Next is the material selection. On the basis of material selection, titanium alloy is the material chosen. This material selection is usually based on the criteria for the jet engine brackets. So, powdered titanium alloy is used for topological optimization. Table on the right shows the mechanical characteristic between titanium alloy and powdered titanium alloy.
This chapter shows the comparison about the old and new design for the jet engine bracket. For the old design was using the conventional method to fabricate part, but for the new design is using additive manufacturing system. After go through the simulation analysis for topology optimization, there are two main comparisons in this project which include the complex shape in the new design compared with the old design. By using SolidWorks analysis, this project can optimize the shape by using the same material which is titanium. This project also can observe the percentage part reduction or part increase, part improvement and mechanical justification analysis. The comparison old design and new design is, for the old design, the shape is simple, more edge, and the size is big compared to the new design. And for the new design, there is no more edge and the size and the shape is complex. And the important thing is the size is small compared to the old design. The mass for old design is 3016.50 gram, around 3 kilogram, and the mass for the new design is 1832.61 gram, around 1.8 kilogram. The comparison stress analysis old and new design is this project put force 1000 Newton, and you can see the highest stress for the old design is 3.748 multiple 10 power of 6 Newton per meter, and the new design is the highest stress is 1.172 multiple 10 power of 6 Newton per meter. And this both diagram show the highest stress is not really appear because this project still can withstand with the force. The comparison strength analysis old and new design is, for the old design, the highest strength is 1.278 multiple times power of 5, and the new design, the highest strength is 8.148 multiple times power of 6. This result show the new design have the highest strength compared to the old design, and if you can see the both diagram, at old design it show the more red mark compared to the new design. For the conclusion, from the drawing analysis that this project come out by using SolidWorks, this project show the old design that use conventional method have high mass compared with the new design. The mass reduction is 39% using the 3D printer. For the stress and the strain analysis, the new design has a little bit less compared with old design due to the weight of reduction. Moreover, the strain of the new design has high strain compared to old design, but it still can support the same force of 1000 Newton. When this project goes to the economical, of course, the new design better than the old design because the weight of part is reduced and no need more material. Besides that, the advantage using 3D printer is the material is added, which is opposed to subtractive, such as conventional method, using the topology optimization to reduce the weight. This project is suitable for aircraft because they need lightweight part of material.
Okay, finally, this is the conclusion of this project. First, students able to demonstrate the capabilities of AM through this project assessment. Second, AM enable the designer to redesign the product without changing the integrity and strength of the product. Okay, finally, AM allow to make a creative freedom in planning without having worry about the cost and time. Thank you.